I work in the Foundry at Ginkgo Bioworks. My job is to make that Foundry easier to understand. These videos are called Foundry Theory, so I guess I owe you a definition of what a Foundry is. What is a Foundry for biology? A Foundry is a physical place that is purpose-built for making biology easier to engineer. That's it. That's the video. Are we good? Are we? Okay, maybe I can expand on that a little bit. First, let's talk about why we need a foundry. Biology is an amazing technology for making stuff. Everything that you see out there in the living world, it built itself from carbon and other elements collected from the environment. And everything that biology does, it does by following instructions written in DNA. That makes biology a programmable manufacturing platform that runs on a universal language, DNA. If you can read, write, and edit DNA, you can, theoretically, make anything that biology can make with all the advantages that biology has. It's precise down to the molecular level. It can self-replicate and therefore scale. It's sustainable, biodegradable, and beautiful. Biology is beautiful. The Foundry is a place where that DNA programming can happen. We write the DNA sequences that contain the instructions for a cell to make something. It might be a medicine, flavor molecule, an enzyme for green chemistry, new kind of vegan leather, anything that biology can make. Those pieces of DNA are transformed into a microbe like yeast or bacteria. The microbes are cultured in incubators and then tested to see if they're making the right stuff in the right quantities. That's the work that's happening inside a Foundry. What that looks like the first time you walk into a Foundry is a bunch of robots moving around drops of liquid. Biology is very wet science. So most of the operations involved in engineering biology are some version of mixing drops of water. If you want to think of a Foundry as a place for mixing drops of water in extremely precise ways, you've got the idea. One drop of water might contain a piece of DNA. Another one has the cells that are going to take up that DNA. One water drop is the medium that we're going to feed the growing microbes, and another one might be used to measure the products that they create. We need these liquid handling operations to be small, precise, and fast as possible. Small because they contain expensive reagents like DNA. Precise because this is engineering and we need consistent, reproducible results. And fast because it allows us to test more DNA designs, collect more data, find the best performing microbes. If you want something done small, precise, and fast, automation is the answer. But I don't want to over-index on just the automation infrastructure of the Foundry. That's just the most visible part of the story. You also need the custom software that runs all those robots. You also need the data infrastructure to manage all the data that they generate. You need the human experts who know how to engineer biology. And you need the social structures, the organization that lets them all work effectively. Like anything worth doing, engineering biology is fundamentally, it's about humans working in good teams with good tools. My favorite analogy for biology Foundry in the tech industry is a microchip fab. A chip fab is built to move silicon in extremely precise ways. A Foundry is built to move water in extremely precise ways. It's a process that benefits from very specialized equipment and infrastructure, so the facilities are large and centralized. The output is an enabling technology, but not a final product. Just like the integrated circuits that come out of a chip fab are not used directly, they're sold to the electronics industry, which turns them into products. And similarly, the engineered organisms created at the Foundry are not used directly, they're sold to developers in different bio-based industries who use them to make their products. So that's a Foundry. Physical place that is purpose-built for making biology easier to engineer. The internal workings are complex so that the output can be very simple, a microbe that makes something. Medicines, materials, flavors, cosmetics, agriculture, energy, green chemistry. The Foundry can isolate and focus on this very complex problem of DNA programming so that all the developers who use the Foundry platform can focus on their products.